Let's solve the 20th question. A certain vase contains 4 flowers, one red, one blue, one yellow, one white. Maya the bee sat on every flower in the bouquet only once. She started with the red flower and she did not fly directly from the yellow to white flower. In how many ways Maya can sit on all the flowers? So it starts always with AR, then suppose it's blue, yellow and white, blue, white, yellow, white, yellow, blue, white, blue, yellow. It is yellow, white, blue and yellow, blue. These are the different combinations possible. Of this, yellow to whites directly is not allowed, so this is not a combination, and yellow to white, this is also not a combination. So the remaining are 4 possibilities, so the answer is D, 4. Let's move on the 21st question. At 6:15 a.m. Casper the friendly ghost vanished, and the crazy clock, which had been showing the right time until then, started to run at the right speed but backwards. The ghost appeared again at 7:30 p.m. that same day. What time did the crazy clock show at the moment when the ghost appeared? So now we find the exact time, the right clock. If the clock runs right, then the ghost disappeared at 6:15 a.m. and it reappeared at 7:30 p.m. So what is the difference between this time? It is going to be like 6:15 a.m. to 6:15 p.m. It is 1 hour, plus there is an hour and 30 minutes after, an hour and 15 minutes after the 6:15 p.m. right? So it is totally 2 hours and 15 minutes. So now we have to, it is 13 hours and 15 minutes. Okay, so now we have to move the clock backwards. So 6:15 a.m. means today. Okay, so it backwards it is 6:15 p.m. and we have to move one more hour and 15 minutes, that is 5 p.m. the day before. So the answer is A. So this is the right clock, it is 6:15 to 7:30. The difference is 13 hours and 15 minutes. This clock is the crazy clock, okay, which moves backwards in direction for 13 hours and 15 minutes, and it gives the time 5 p.m. Okay, now we will move on to the next question. 22nd. The square of a 3 into 3 table were filled in with numbers as shown in the picture. In one move, we can switch any 2 numbers. What is the smallest number of moves like this that we need to make to get a table in which the sum of the numbers in each row is divisible by 3? For this, we have to find the sum of the number. For this, it is 11. 10. And for this, it is 22. And here the sum is again 10. So none of this number is divisible by 3. We have to randomly move the numbers in between each rows and see to that it have a number that is divisible by 3. Either it should be 9 or 12 in this, or 21 in this, or 24, right? Here also 9 or 12. So it's just random possibilities. We just keep on shuffling the numbers. Now I'm going to write the exact change by which we got this answer. So the first time I'm going to shift numbers 8 and 7. Okay, so it's going to be 4 5 1 7 10 4 and 8 1 2. Then I'm going to shuffle this 5 and 1. So it's going to be 4 1 1 7 10 4 and it's going to be 8 5 and 2. Now the sum is 6. Here it is 21 and here it is 15. All these three numbers are divisible by 3, and so I have made two shifts, right? And I have found the correct answer. So the possibility is 2, option B.